Okay, class. Assalamualaikum. Okay, so we proceed to chapter 4G. Okay, in this chapter, you will learn about standard solution, primary standard, secondary standard solution, and the last one is a stop solution. So, at the end of this chapter 4G, you should be able to define the standard solution, primary standard solution, secondary standard solution, and also stop solution. And then you need to know you can differentiate the characteristic of primary standard and also secondary standard solution. Okay, we move to standard solutions. So standard solution defined as a standard as a solution whose concentration are known to high degree of accuracy. So meaning that known of solution and known of concentration. So the characteristic of this standard solution is maintains its concentration over a long period of time. So from months to years after the preparation. This will eliminate the needs for re-standardization. Okay, so mudahlah untuk anda if let's say you ada solution yang betul-betul dia punya concentration is maintained, so it should be okay. So contoh apa kalau ada kat rumah kita ataupun dekat industri, contohnya adalah contoh air sirap. Contohnya dia punya stock solution of air sirap tersebut. That one is a standard solution. Ataupun contoh you ada cordial tu adalah contoh standard solution jugalah. Alright. Must be able to undergo rapidly stoichiometry and complete reaction with the analyte. So this one is for standard solution. A standard solution can be prepared in either of two ways. First is primary standard. If carefully weighed, dissolve and dilute accurately to a known volume. So for example, macam kita buat dalam lab hari tu, how to make a standard solution. First, you need to add you punya material, and then you weigh, and then you dissolvekan, you transfer into you punya canonical flask, the volumetric flask, and then you add the solution until the calibration mark, then you place a stopper. So you know the concentration of you punya solution and non-solution, and then you need to make sure you need to label. Right, its concentration can be calculated from this data, as I mentioned. So a solution is made to an approximate concentration and then standardized by titrating an accurately weighed quantity of a primary standard. So there is the two types of standard solution. First is primary standard solution, and the second one is secondary standard solution. So what is different between primary standard solution and secondary standard solution? So after this, I will tell you. So we proceed to primary standard solution. So a compound of highest purity, and it is used to determine direct or indirectly the concentration of the standard solution for a titration. So ideal primary standard for volumetric titration should have the following characteristics. So this is characteristics very important. So if let's say the first character is highest purity up to 99.99%. So if let's say if you refer to your final exam question, normally they ask you what is the characteristic of primary standard solution. So kalau you letak jawapan the highest purity saja, so salah. Kena ada perkataan complete which is up to 99.99%. And then in terms of stability, the substance should be stable at room condition or during heating and does not react with the constituent of the atmosphere. So meaning that it is non-hygroscopic material. Free from hydrated water and should be non-hygroscopic, as I mentioned tadi. So non-hygroscopic ni tidak akan ada reaction with the constituent at the atmosphere. Dia bukannya lah jenis yang absorb water from surrounding. Soluble in titration medium, high formula weight to minimize weighing error, and easily available at reasonable cost. Okay, so for example, primary standard, the number of primary standard available is very limited, such as sodium carbonate is one of example of primary standard. Sodium chloride, arsenic trioxide, calcium carbonate. Now this is the structure of the calcium carbonate. Oxalic acid crystal, 99.5%. So it's very highest purity. Alright, why not use HCl or sodium hydroxide as a primary standard? Because primary standard should essentially available in pure form, stable towards light and heat, and react in a stoichiometric proportion. So as I shown to you in during experiment, so the sodium hydroxide pellet. So actually it is hygroscopic material. When you place the sodium hydroxide dalam pada tapak tangan awak, dia akan cepat saja mencair, dia akan absorb water. Okay, so that's why kita tak classify this sebagai primary standard because dia tak stable towards light and heat. The exact concentration of any hydrochloric acid solution is not known unless it is prepared from standard ampoules. Okay, the standard ampoules says kat bawah ni, which is solution yang kita prepare, very concentrated standard solution, dan diseal terus dengan menggunakan glass. So bila kita nak guna pakai, kita kena pecahkan dia. So normally kat mana kita boleh tengok ampoules ni? Ampoules ni biasanya bila you ada adik-adik kecil or baby, bila pergi cucuk dia punya vaccination, so doktor akan pecahkan daripada keluarkan daripada petais, dia akan keluarkan ampoules ni. So boleh dipecahkan, baru dia sucks with the picah jari, and then baru dia inject pada baby tersebut. Itu adalah ampoules. Very dia punya concentration is tahan lama, dan dia adalah primary standard. Alright, sodium hydroxide cannot be weak is in open air, as I mentioned tadi lah, because they readily absorb water and carbon dioxide from the air. So secondary standard, secondary standard is a less pure than primary standard, less stable and more reactive than primary standard. Okay, more reactive meaning that dia mudah untuk react dengan environment. So kalau contoh tengok acid pun sangat mudah, ataupun sodium hydroxide tadi pun sama, saya mention tadi. So titrated against primary standard, this is common, this is a norm. Okay, the priority on or the concentration of a secondary must be established by carefully stoichiometric analysis, usually against primary standard, as I mentioned. So example, HCl, nitric acid, sodium hydroxide, potassium permanganate, and silver nitrate is example for secondary standard solution. Okay, and the last one is a stock solution. So I already teach you in chapter 1 also. So stock solution is a large volume of common reagents such as HCl or sodium hydroxide at a standardized concentration. So as a concentrated, that is a solution to be diluted to some lower concentration for actual use. This term is commonly used in analytical chemistry for titration procedure, where it is important that exact concentration of solution are used. So this known as a stock solution. So end of chapter 4D, meaning that end of chapter 4. So after this, I will give you the tutorial question. So, and at the same time, I need you to do a revision by your own by using the final exam question. So you have a 5 semester yang lepas punya soalan final exam, so please tolong try buat. Okay, so usaha di tangan anda, bukan di tangan saya. So jika anda berusaha, insyaAllah anda akan berjaya. Percaya pada diri.